Hello everyone, and good afternoon to my talk. I'm speaking on Microsoft Sentinel attack range. Just a little bit about myself. I've been in the industry for over 4 years, and I've worked in various sectors, from like finance, consulting, and also healthcare. I came through as a SOC analyst, normal first line of the queue, working tickets, and if you've been in that role, you know how it is. In terms of like alert fatigue, continuous escalation of alerts, and also in terms of being fast, being under pressure to raise out a ticket to customer. So I know what it is like being thrown into a SOC environment without having this skills of what you're saying. You see different kind of threats you're not so used to, you've not seen before. And that was one of the reasons why I built what they call the Microsoft Sentinel attack range. And what this is going to do is give SOC analysts a realistic environment where they can run attacks and also triage, breaking between the blue team and the red team, trying to break the breach between them. I presently work at Coronet as a security engineer, Microsoft Sentinel specialist, and also helping customers make best use of Microsoft Sentinel. I created the Microsoft Sentinel attack range, and I focus on detection engineering, automation, and SOC optimization. And just a side note, this is my first time speaking publicly, so you could just say thank you. The problems. How do we validate detection rules before an actual attack really happens? Most organizations don't have the capability. They just do, most of things are just like theoretical detections. They are not, there's no equals to reward effectiveness. Meaning, if you just create a rule out of your own head or like based on like an article, but without running a real attack, you don't know if that rule is effective or not. There's been a time where I created a rule and I ran an attack and the rule went purely silent without generating any alerts. So trying to stop those kind of loopholes, trying to move those kind of rules to production is what Sentinel attack range is going to help you with. Production testing is risky and disruptive. Also, SOC teams need a realistic training environment. The detection feedback loophole requires continuous testing. Current approach from the previous slide, production testing is very risky and it can harm the business. So trying to make any of your testing in a live environment is risky and can cause a lot of consequences for the organization. Pop team exercises. This is costly and also time consuming. Not every organization have the budgets. Also, even if it's going to be approved, it takes probably a couple of months to get a purple team exercise approved. And also this is being done probably maybe quarterly or twice a year. So it's going to be as often as just having a normal lab you can spin up and destroy your own. There are generic labs environments out there. Out the box, most of them make use of like Splunk, but we don't have a Sentinel focused one, like Microsoft Sentinel focused one. Also to mention, I'll be mentioning Sentinel most times. It's not Sentinel 1, but Microsoft Sentinel. And manual setup, there'll be a lot of inconsistency, hard to maintain, and also time consuming as well. Trying to spin up a lab, you're not sure of how many VMs was spin up in the last one, spinning up another one again. So there'll be a lot of inconsistency in there. So about what I built, which is a Microsoft Sentinel attack range, is an open source framework, meaning anyone can make use of it for testing Sentinel detections. Analysts, so for example, you could run an attack and your analysts will get used to those kind of attacks. So when they say it in real life, in their prod environments, they're familiar with this kind of investigation. So when you run an attack on a normal day, an analyst, something has not seen before, will take a long time before, they try to triage instead of 15 minutes. But once you're used to this kind of, seeing this kind of attacks before, your triage time will be faster. It's fully automated Azure native attack lab, meaning exactly what is in here is what is in your production. Exactly, so there's no like, it's an half-bake, it's not half-bake. It's exactly what you have in your production, how you set up Sentinel live in your prod environment is what you're going to have here as well. It comes with about 20 pre-configured rules and also data connectors. And complete infrastructure as a code and deployment. So in this instance, I made use of Terraform Terraform is one of the IAC which I use to create every infrastructure which is needed. And we are going to see it in a couple of slides coming soon. Okay, so the architectural overview. Azure infrastructure, all the VNets, virtual security group, virtual machines, which are going to come with extensions, which is AMA, Azure Monitor Agent is the one that's going to get all the logs from the machine that are going to spin straight to Sentinel, log analytical workspace. And also WinRM is what is going to come also with WinRM extension, which Ansible is going to use to get into the environment and get them ready for Atomic team to start the attack. Get the environment ready. I'm going to spin up about Windows DC workstation, Kali Linux machine, which is our attack machine, Microsoft Sentinel workspace, log analytical workspace, and also every possible attacks simulations which you can run. So here's just a diagram overview of how the architecture looks like. Okay, so the deployment flow. The first thing I'm going to do is just git clone the repository, which don't worry, at the end of the slide you get a barcode which you can scan that will take you directly to the repository. First thing I'm going to do is just change what is in the Terraform servers. And what's Terraform servers? That's just where like variables which you will need. Other modules are going to make use of. So in there, you're changing your passwords and also the region where you want it to be deployed into. Also, if you leave it by default, every resource that we created will start with a prefix of attack range. So you can change that to anything you like if you want to. But that's just in there where you can change your password and also the region where you want it to be deployed to. And also, ignore the IP allowed part, because once you run the attack, I'm going to show you as well, it's going to update itself. We just have a single command just to build this whole thing. A single command deployment, which is attack build. It's going to build out every whole infrastructure, which we are going to say in coming slides. Infrastructure automatically deployed. The detection rules deployed as well, also all data connectors. And that's all we're ready for attack. So attack capabilities. So in here are all the available attacks you can run. It comes with over 30 plus attacks, which you can run. So starting from one of the tactics, which is discovery, network scanning, credential hunting, system enumeration, then credential access, password dumping, brute force, credential thefts, then persistence plus execution, registry keys, schedule tags, password techniques, and lastly, defense evasion plus impact, log clearing, time stomping, and ransomware simulation. So we've got multiple attacks which you can run on just with a single command. And here comes pre-built attack sequence. So what are these sequences? So sequence are places where you can run like multiple type of attacks at once. So for example, the recon is going to run things that have to do with like account discovery, process discovery, network discovery, just with one attack sequence. So it's going to run multiple attacks in one sequence. Credential thefts, persistence, and full chain. So full chain, I'll say, think of this like a Netflix account where you've got like seasonal movies to watch. So you just pick an episode. You just probably want to watch just one episode or just two episodes. But if you want to watch the full whole movie, which is the whole episode in the whole season, that's like what the full chain is going to do for you. It's going to run through every available attacks you can run. And also, this is not just limited to what the attacks that are there. So meaning if you want to like create your own attack and you want to just test it in there, you can create an Ansible playbook and just add it to it, and you can run the attack as well. Then cross-platform Windows and Linux attacks. So here comes these are the available analytical rules that comes with it by default. So network scanning detection, credential access monitoring, PowerShell execution tracking, and persistence mechanism, and also like cross-platform attack detection. So this is where detection engineers should actually spend most of their time creating like more detection rules based on the attack which we run. Okay, so here is going to be like a live demo, but due to network and some things are unsure of, so that was why I had to go ahead and make a recorded video, which I'm going to say. Okay, so the first thing which you're going to do, once you get to clone the repo, if you're not new to Azure, this is Azure CLI. So you're not setting up any CLI or anything else. So as I mentioned earlier, everything is Azure native. So this is Azure CLI. Open it up and just get to clone the repository. And once you do that, cd into the directory where everything is Azure attack range. So the first thing it's going to do now is just setup. And what the setup is going to do just to make sure your environment is ready. Checking out for is Terraform there, is Ansible there, is Python there. Making sure it's there, and also making sure you have a SSH key. If you don't have one, it's going to prompt you to create one for you. And you can ignore the SCD after that. That was just me trying to max my subscription ID. So that can be ignored. So once the attack is done, once setup is done, it's going to tell you to make sure what is in your attack range YAML file matches what is in your Terraform.tvs. And after then telling you are ready to build. And before that, I created an help command just to make life easier for everyone. So any kind of attack, any kind of commands you want to run, they're all available in the help command, which is what I'm going to show you now. So how to build, destroy, or updates. And also every possible attacks and every possible sequences in there. I'm trying to bring. Okay. So the next thing, which is the one single command, which is going to build everything for us. Attack range build. And if you remember when I was explaining about Terraform TVAS, where I said you can ignore the IP. So automatically, it's going to check your present IP. If you're new to Azure CLI, every time you launch Azure CLI, it's going to assign a new IP to you every single time. So you can ignore the IP, that's not my IP. And so it's going to update this IP now to your Terraform TVAS, which once everything is spin up, you have access to the whole network. Sorry. Okay. So this is going to build every whole infrastructure. As you can see, this was built all within 8 minutes, which I'm going to show you all the resources that were built. And our environment is ready for attack. So here's the output of all resources that were built. So meaning every virtual machine needed, all the whole extensions needed. So the next is going to be every available attacks. So these are all the available attacks in there, over 30 plus of them, which we can run. So from process discovery, network discovery, account discovery, up straight down to mimic execution, ransomware simulations, all over 30 plus attacks which are there. And as I mentioned earlier as well, you can create your own Ansible playbook and add to it. So the next will be the sequencers, which, as I mentioned previously, these are going to run like multiple attacks. So, for example, if I'm going to run the recon now, it's going to run all anything has to do with like discovery. So, account discovery, process discovery, network discovery, system info discovery. So, every single discovery is going to be run through recon. And this is the Azure portal, which I feel most people will be familiar with, showing every resources that we've just built. And going straight down to the most interesting one, which we want to say is Sentinel, what we just set up. So for people that don't know Sentinel, it's the same tool, just like Splunk. As you can see, all our analytical rules are inbuilt there automatically, and also comes with its own data connectors by default. And we're going to go ahead and just check the machines which we just spinned up not long ago. Are they sending in logs directly into the SIEM, which we are going to confirm through the now checking the logs. So I'm going to use this log for the attack Kali machine. And I know that may be very small, but yeah, you can see the attack Kali machine, meaning yeah, logs are coming in for our syslog. And same thing for security events, where you can see our Windows DC and also the Windows workstation. So also you can add multiple workstations automatically, all the logs as well will come in straight. At the moment, it's just 3 workstations we've got in there. So that's all infrastructure ready, and the next thing is just running attack in here, and I'm going to be running the full chain attack, which is going to run through every available attacks we've got. So starting from network discovery straight down to ransomware simulation. And for each attack, it's going to tell you the ones that failed and the ones that failed, the one that were unreachable, and it's going to tell you the one that was skipped. So if an attack, one of the attacks should fail, it's not going to stop the overflow. It's going to just ignore that and move straight to the next available attack. And sometimes what happens there is maybe WinRM is not set up properly or is not fully loaded. That's when, so just run an update and run the attack again. That should be fine. As you can see, this took over an hour. Yeah, that took over an hour to run because I ran through every available attacks. And this is unified. So unified XDR, which some people might not be used to this dashboard. So this is where you've got Defender and also Sentinel in a single screen. So you can see everything happening in your Defender and also everything happening in your Sentinel. And as you can see from our attacks, which we just ran now, over 27 alerts were generated. And we're going to see also our machines, which are at high risk already. And it's just a glance of available incidents in there. So also going to show you in Sentinel, we've generated over 26 incidents already from the attack which we ran. So that's all for this, and once you're done, just a single command as well, just to destroy everything, and within 3 minutes, all the infrastructure is gone. So you don't have to worry about incurring any other fee or any additional fee. Just once you're done, automatically destroy. Yeah, so what are the success metrics? Which is detection coverage across MITRE techniques, alert generation rates and timing, also false positive evaluation, meaning like an alert and a rule can generate multiple alerts. So that's where you just go back in there and like tune it and have trying to mature the analytical rule which you just built. Alert fidelity and also context quality and easy cleanup. Okay, so to set this up, normal Azure subscription and just basic CLI knowledge. But if you're new to Azure in general, you could sign up for 30 days free Azure, which are going to give you about 200 credits, and you can spin up this lab multiple times. If you spin up this lab once and probably run like 2 or 3 attacks, you'll be charged for probably less than $12. And the major thing that incurring fee is just a public IP assigned to your VMs. Also, about the GitHub, there's a barcode at the end. This is going to link you straight there, so don't bother about it being so long. And there's a medium article I wrote on it as well, with screenshots on how to walk through each of them, which is well detailed than this. And in total time investment, probably less than an hour. As you can see, the spin up took less than 9 hours to generate all the infrastructure. Running a single attack would take basically between 5 to 10 minutes just for one attack. So you run 2 attacks, probably take a maximum of 20 minutes. So it's very easy to deploy. So for example, stock managers or like sales team, where they need to show Sentinel demo for a customer. So you don't have to start getting the scene in advance. It's something you can spin up even before your scheduled meeting and just spin it up, run a single attack and walk your potential customer through it and tell them this is how it works, this is how our analysts pick up, this is how our analysts prioritize tickets, and this is how the analysts also escalate tickets. And key takeaways, validation detection rule before real attack occurs. Move beyond theoretical security to proven controls, and also provide realistic training for SOC teams, meaning just making SOC teams more familiar with techniques being used out there. So let them see real realistic alerts, realistic simulations, not just slides or reading. Let them going through there and going through the try to investigate the real attack, like real simulation, not just reading of like slides. Also, enable continuous improvement of detection rules, and also bridge the gap between the red and blue teams. No organization are fortunate enough to have like a red team. So in here, run the attack as a red team, and also go into KQL and like try to defend with some KQL queries. So that is if you scan the barcode, it's going to take you to the repository where it's going to take you straight to the GitHub repository where the link to the article is, and also everything that's to do with the project. And also, I welcome anybody that wants to try to improve this or give feedback on this. You can submit a pull request, and I'm happy to collaborate. Also, feel free to ask me any question now or reach out to me later. And I'd also like to say a very big thank you to Mark and also Tom for helping me be able to be confident enough to speak of this. Thank you very much.
Does anyone have any questions for Albert? Yes.
Sorry, the destroy command at the end, does that destroy all the infrastructure created during the test?
Okay, so it asks the destroy at the end, does it destroy everything created? So yeah, it's going to destroy all the old infrastructure created. So
is there any way to delete the infrastructure that occurs across and keep the log analytics workspace, just so you can carry on working through detection and KQL queries without the VNet at the end of the package?
Yeah, it's possible. So if you perhaps just delete that from resource group, just remove the virtual machines, 3 of them. The logs will still be in log analytics workspace.
Any more questions for Albert? In which case, awesome talk for the first time.